everyone, welcome back to Conquering Algebra 2. This is lesson 35. There's three concepts we're going to talk about in this lesson. We're going to talk about fractional exponents. Whenever our exponent is a fraction, what do we do with that? We're going to talk about inscribed quadrilaterals within circles and finding those missing angles. But the first concept we're going to talk about is talking about the angles within a polygon. So we have all different types of polygons. There's one thing that we have always said over and over and over again. All three angles of a triangle are going to equal 180 degrees. Always, forever, done. And because we know that, we can know the sum total of all the other shapes, all the other polygons, because we know this. So when we have an abnormal quadrilateral, we all know quadrilateral is going to be 360 degrees, but it gets more complex. So I'm going to use the quadrilateral as an example to prove that this system works. So we don't know all four angles from previous knowledge. We know that it's going to equal 360, but let's prove why. So when I have a quadrilateral like this, all I have to do is find a diagonal. And I see that I have split this into two triangles, okay? So that means this triangle has 180 degrees and this triangle has 180 degrees. So 180 times 2 equals 360 degrees. And so that is why we know this. So let's go with a pentagon. Let's make it bigger. So from one angle, I can make two diagonals, okay? Two diagonals means I have three triangles. So I have C, D, and E. And with those three triangles, I can do 180 degrees times 3, and that's going to give me 540 degrees. So that's going to be the total for the interior angles of a pentagon. So to make this simple, so that we're not always having to draw out a shape, find all the diagonals, there is a formula that we can use. And it is going to be the number of sides minus 2 times 180 and then degrees. So that's going to be your sum total for whatever polygon you are working with. So just proving it, we had a pentagon. So instead of n, I'm going to put 5. So 180 times 5 minus 2. So that's going to be 3 times 180. And then we're back to where we started. So this is going to be a concept that's going to help us later in math. So let's go ahead and do a practice problem. Okay, so the practice problem they give us for this concept is actually not about what I just instructed. It was the other part of this lesson, and that is dealing with the exterior angles. It doesn't matter how many sides we have in this polygon. The total of our exterior angles, which is going to be all of the angles outside of the shape, imagining that they were still continuing in a straight line like they are here, it will always, always, always be 360 degrees. So in this practice problem, they give us all the exterior angles with the exception of x and x plus 55. But we know that all of these added together, all 6 angles is going to equal 360. So we can set that up as an equation and solve for x. So we have x plus 55 plus 65 plus 50 plus, I'm going to jump down here, 40 plus 80. And so we can add all of this up, equals 360. Okay, so let's add this up and then solve for x. Okay, so we have 2x plus 290 equals 360. We're going to subtract the 290, which gives us 2x equals 70. So x is going to equal 35 after we divide by 2. So x equals 35 degrees. And now they want to know why. So I need to plug 35 in here. And 35 plus 55 is going to equal 90. And since this is a straight line, I know that y will equal 90 as well. All right, so that's it for solving for exterior angles and then also using that to find interior angles. Just quick side note, this is a hexagon. It has 6 sides. So if we did want to find the total for the interior angles, what I would do, I'm going to switch colors real quick. is I would take our formula, 180 degrees times the number of sides minus 2. So we have 6 sides, so I'm going to say 180 times 6 minus 2. So 180 times 4, which would be 720 degrees. So that would be the total of all 6 angles. And that is how we solve that. The second concept in this lesson is talking about inscribed quadrilaterals. And there's another math fact that we want to learn here, and that is if there's a quadrilateral inscribed within a circle, then opposite angles are going to be supplementary. That means angle A plus angle C will equal 180 degrees, and then also angles B and D will equal 180 degrees. So that's a nice little shortcut for us finding missing angles whenever the quadrilateral is inscribed within a circle. So let's do a practice problem. Okay, so here we have a quadrilateral inscribed inside a circle. They want us to find x, y, and z. So starting with x, we know that x plus 80 is going to equal 180. So we can say 180 minus 80 equals x equals 100 degrees. So there is x, and then we know that 75 and y should equal 180. So 180 minus 75 equals y equals 105 degrees. So there's part 2, and now z. Z is going to take just a little bit more work. We see that z and 50 together are the inscribed angle of 80. So we know that if the inscribed angle is 80, the central angle is going to be that times 2. And so we have 80 times 2 is 160 degrees. 160 degrees is the central angle. And obviously this is not drawn to scale. Clearly, yeah, no. Okay, so we know that 160 is going to be z plus 50. So 160 minus 50 will give me angle z. So angle z is 110 degrees. So we have solved for all 3 of our missing sides. There wasn't a whole lot of big math number crunching. If we can just remember some of these small rules, it's going to save us a lot of work and a lot of time. The last concept in this lesson is dealing with fractional exponents. Something like 9.5. So before I get into that, I want to recap what we already know. If we had 9 to the second power, that would mean 9 times itself, which we already know how to do that. If we had 9 to the negative second power, that would be saying 1 over 9 times itself, because the negative means I'm going to move its position from numerator to denominator or from denominator to numerator, and then the 2 is telling me how many times I'm multiplying it. So we already know what happens when our exponent is a positive whole number, when it is a negative integer, but now let's talk about fractions. So squared means times itself. Half means the root. So this would be the same as saying the square root of 9. So something times itself, and that would be 3. Okay, so I'm going to write some of these keys over here in this top corner for us to reference as we go through a couple of practice problems. Okay, so our first practice problem is 4 to the negative 1/2. So we have 2 things happening. Our exponent is negative, and it's a fraction. So negative means I'm going to flip it. So this will become 1 over, and then we have 4 to the 1/2. So that would be the square root of 4. So this would be 1/2. That would be our answer. The next one, again, we have a negative, and in this time, instead of a square root, we have a cube root because our exponent is 3, not 2. So we're going to flip it, put it in the denominator, and then also this negative stays outside. If they wanted the negative included, they would have listed it in parentheses like this, but they didn't, so the negative does not get messed with until the very end of the tour. So we have 27, but it is going to be cube rooted, and then that negative is hanging out there. So the cube root of 27 is 3, so we have negative 1/3. Okay, this next one, we still have 2 things going on. We are cubing this and square rooting it. So I personally am all about making numbers smaller before I have to multiply, so I'm multiplying small numbers. I would not cube 16 and then try to square root it. Why would I make math hard on myself and do 16 times 16 times 16 whenever I'm about to square root 16 and make it a smaller, much more manageable number? So I'm going to square this first. So I would say 16 square rooted, and then I would put that cube up here. So the square root of 16 is 4. So 4 cubed is 64, and that is a much more manageable number to multiply with or without my calculator. And all of these can be entered in your calculator. Just make sure that as you are listing your exponent, that denominator is being included as an exponent and not getting counted as 4 to the negative 1 divided by 2. You don't want it to read that because obviously you're going to get a very different answer. Okay, last one. All 3 situations are happening here. We are squaring, we are cube rooting, and it is a negative exponent. So we're going to have to flip the situation. So we have negative 1 over, and then we have the cube root of 8, which will be squared. So the cube root of 8 is 2. So negative 1 over 2 squared, so it would be negative 1 over 4. So that is it. This is how you handle fractional exponents. All right, and that's it for today with lesson 35. I hope this was really helpful. If there's any questions or confusion, please feel free to leave a comment below. I'd love to help you out. And my Algebra 2 students, I'll see you guys in class.